Good morning everyone. So today let us start problems based on dot product. Okay. First one, if vector A and vector B are given, find vector A dot vector B. So here given vector A and vector B are in component form. Therefore, the dot product in component form formula is A1 B1 plus A2 B2 plus A3 B3. Okay. So let us consider the given. Given vector A 3 I cap minus 2 j cap plus 4 k cap. That means in general form A1 I cap, A2 j cap, A3 k cap, and vector B is minus I cap plus 3 j cap plus 4 k cap. So in general form B1 I cap plus B2 j cap plus B3 k cap. Okay, we have to find vector A dot vector B. That is equal to formula is A1 B1 plus A2 B2 plus A3 B3. Okay, so A1 into B1 3 into minus 1 plus A2 into B2 minus 2 into 3 plus A3 into B3, that is 4 into 4. So here 3 into minus 1 is minus 3. So plus into minus, minus 2 3s are 6 plus 4 4s are 16. Okay. So minus 3 minus 6 is minus 9. Minus 9 plus 16 is 7. So therefore we get vector A dot vector B equals 7. So next one, if vector A and vector B, again given vector A and vector B in component form, we have to find the dot product. That means we have to use the same formula, that is vector A dot vector B. Formula is A1 B1 plus A2 B2 plus A3 B3. Okay. So here A1 value is 2 into B1 6 plus A2 is 2 into B2 minus 3 plus A3 minus 1 into B3 is 2. So here 2 6 are 12 plus into minus minus 2 3s are 6 plus into minus minus 1 2s are 2. So therefore we get 12 minus 6 is 6, 6 minus 2 is 4. So therefore vector A dot vector B equals 4. So next one, find the angle between two vectors. Angle means we have to find theta. Okay. So given vector A and vector B are two vectors with magnitudes root 3 and 2. So magnitude of vector A is root 3 and magnitude of vector B is 2 respectively, having the dot product is root 6. So therefore here given magnitude of vector A equals root 3, magnitude of vector B 2, vector A dot vector B equals root 6, and we have to find theta, angle. Okay. So we have angle formula. What is cos theta? Cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. So therefore cos theta equals vector A dot vector B value is root 6 by magnitude of vector A root 3 into magnitude of vector B. Cos theta equals root 6 can be written as root 3 into root 2 by root 3 into, here we can write 2 as root 2 whole square, right? So here root 3 gets cancelled, 1 root 2 gets cancelled. Therefore cos theta equals 1 by root 2. Here we have to find theta. So therefore theta equals, take this cos to the right hand side, it becomes cos inverse of 1 by root 2. What is cos inverse of 1 by root 2? So cos inverse of 1 by root 2 is 5 by 4. So next one, find the angle between two vectors, vector A and vector B. Again, we have to find the angle theta. So, we have to find the angle theta, okay, with magnitudes 1 and 2. So, here given magnitude of vector A is 1 and magnitude of vector B is 2, okay. Respectively, having vector A dot vector B equals 1. Again, by using same, previous problem is similar to this problem, right? So here, cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. Cos theta equals, so vector A dot vector B value is 1 by magnitude of vector A is 1 into magnitude of vector B 2. So therefore cos theta equals 1 by 2. So theta is equal to, if we take this cos to the right hand side, it becomes cos inverse of 1 by 2. So theta is equal to cos inverse of 1 by 2 value is pi by 3. So next one is find the angle between the vectors, vector A and vector B. So here we have to find the angle, means that is theta. We have angle theta formula. What is the formula? Cos theta is equal to vector A dot vector B by magnitude of vector A into magnitude of vector B. In previous problems, they have given the values directly, right? But here there is no direct question. So here given only the vectors in component form. So we have to find the values of the dot product and magnitude of each vectors first. Okay. So first let us take the given vectors. So here given vector A equals I cap minus 2j cap plus 3k cap. Okay. Then find the magnitude of this vector now. So here magnitude of vector A equals, what is magnitude formula? Square root of x square plus y square plus z square. Use that formula. Square root of, so here x value is 1. 1 square plus minus 2 whole square plus 3 square. So here therefore square root of 1 square is 1 plus minus 2 whole square 4 plus 3 square 9. So here we get root 14. That is magnitude of vector A is root 14. So next consider vector B. So vector B is 3i cap minus 2j cap plus k cap. So find the magnitude of vector B. So magnitude of vector B equals square root of 3 square plus minus 2 whole square plus 1 square, that is equal to square root of 3 square is 9 plus minus 2 whole square 4 plus 1 square is 1. So here we get again root 14. Okay. So here next we have to find the dot product or scalar product of that vectors. Since these two vectors are in component form, so dot product component form formula is A1 B1 plus A2 B2 plus A3 B3. So now substitute the values. So here A1 is 1 into B1 is 3 plus A2 into B2, that is minus 2 into minus 2 plus, so A3 into B3, 3 into 1. So here we get 3 into 1 is 3, minus into minus becomes plus, so plus 2 2s are 4 plus 3 into 1 is 3. So if we add this one, we get 3 plus 4 is 7, 7 plus 3 is 10. So therefore vector A dot vector B value is 10. Okay. So now substitute in this formula. So cos theta is equal to vector A dot vector B value is 10 by magnitude of vector A root 14 into magnitude of vector B root 14. So here cos theta equals 10 by Root 14 into root 14 is root 14 whole square. Square root and square gets cancelled. We get 14. So here 2 5s are 2 7s are. Therefore, we get cos theta equals 5 by 7. Okay. So, but here we have to find only theta. Take this cos to the right hand side. Theta is equal to cos inverse of 5 by 7. 5 by 7 is not the standard value. Therefore, this is the angle theta. So, next is show that the vectors vector A and vector B are orthogonal. Orthogonal means it is nothing but perpendicular. See here, we have to show that these two vectors are perpendicular. I have told you that if vector A and vector B are perpendicular, then what is the condition? The scalar product must be equal to 0. That means the dot product is always equal to 0. Okay. Suppose if we prove that these two vectors, if we take the dot product of these two vectors, then the value becomes 0. Then we can clearly say that the two vectors are perpendicular to each other. Okay. So here given vector A 7i cap minus j cap plus 2k cap and vector B 2i cap plus 6j cap minus 4k cap. Okay. Since these two vectors are in component form, so we have to consider the dot product formula as vector A dot vector B is equal to A1 B1 plus A2 B2 plus A3 B3. Okay. So now let us apply. Vector A dot vector B equals A1 into B1 7 into 2 plus A2 into B2 minus 1 into 6 plus A3 into B3 2 into minus 4. So vector A dot vector B equals, so 7 into 2 is 14, plus into minus minus 1 into 6 6, again plus into minus minus 2 4s are 8. So here 14 minus 6 is 8, 8 minus 8 is 0. Therefore vector A dot vector B equals 0. Here we are getting dot product is 0 means the two vectors are perpendicular to each other. Okay. So this implies vector A and vector B are perpendicular or orthogonal. Orthogonal. So next is if vector A and vector B are perpendicular. So here given vector A and vector B are perpendicular. Find lambda. We have to find the value of lambda. So okay. Given vector A, that is 2i cap minus j cap plus 2k cap. Vector B 3i cap plus lambda j cap plus k cap. So given that vector A and vector B are perpendicular. Since these two vectors are perpendicular, the condition is vector A dot vector B equals 0. Okay. So let us apply the dot product. Since these two vectors are in component form, formula is A1 B1 plus A2 B2 plus A3 B3 equals 0. So A1 into B1 3 plus A2 into B2, that is minus 1 into lambda plus A3 into B3 2 into 1 equals 0. So 2 3s are 6 plus into minus minus 1 into lambda lambda plus 2 1s are 2 equals 0. So here 6 plus 2 is 8 minus lambda equals 0. So here take this minus lambda to the right hand side, it becomes plus lambda, therefore lambda equals 8. So next is if magnitude of vector A plus B is equal to magnitude of vector A minus B. Then prove that. We have to prove that vector A and vector B are perpendicular. So perpendicular means the dot product of these two vectors is equal to 0. Okay. So here given magnitude of vector A plus vector B equals magnitude of vector A minus vector B. Here there is no formula to use here, right? So let us square on both sides. If we take square on both sides, magnitude of vector A plus vector B whole square equals magnitude of vector A minus vector B whole square. So here we have the formula. What is magnitude of vector A plus vector B whole square? I have given in the last class, right? That is magnitude of vector A whole square plus magnitude of vector B whole square plus 2 into vector A dot vector B. That is equal to, again by using the formula, magnitude of vector A minus vector B is magnitude of vector A whole square plus magnitude of vector B whole square minus 2 into vector A dot vector B. Okay. So here magnitude of vector A whole square gets cancelled. Magnitude of vector B whole square gets cancelled. So left side we get 2 into vector A dot vector B. Okay. So take this minus 2 into vector A dot vector B to the left hand side. It becomes plus 2 into vector A dot vector B. So that is equal to 0. So here we are getting the same terms. 2 plus 2 is 4. 4 into vector A dot vector B equals 0. If we take this 4 to the right hand side, it becomes 0 by 4 is 0. So therefore, we get vector A dot vector B equals 0. So if the dot product is 0 means, so clearly this implies vector A and vector B are perpendicular to each other. That is vector A and vector B are perpendicular to each other. So this is the proof. So now let us see the next problem. If vector A and vector B, so vector A and vector B are given, then show that the vectors vector A plus B and vector A minus B are perpendicular. So perpendicular means the scalar product is equal to 0. But here we have to prove for these two vectors. That means we have to prove that vector A plus vector B dot vector A minus vector B equals 0. If the dot product of these two vectors is 0, then clearly we can say that these two vectors are perpendicular. Okay. First, let us find vector A plus B and vector A minus B. So first vector A plus B equals, add these two vectors, 5 cap plus 1 cap is 6 cap minus j cap plus 3 cap is plus 2 cap minus 3 cap minus 5 cap is minus 8 cap. Okay. So now subtract the two vectors to get vector A minus vector B. Okay. 5 cap minus 1 cap is 4 cap minus j cap minus 3 cap, that is minus 4 j cap minus 3 cap. Since we are subtracting, the sign changes, it becomes plus. Minus 3 cap plus 5 cap is plus 2 cap. Okay. So now let us take the dot product of these two vectors. Since these two vectors are in component form, so here vector A plus vector B dot vector A minus vector B equals, since these two vectors are in component form, apply A1 into B1 plus A2 into B2 plus A3 into B3, that is 6 into 4 plus, so A2 into B2, 2 into minus 4 plus A3 into B3 minus 8 into 2. So here 6 4s are 24, plus into minus minus, 2 4s are 8, plus into minus minus, 8 2s are 16. So 24 minus 8 is 16. 16 minus 16 is 0. So here we are getting vector A plus vector B dot vector A minus vector B equals 0. Since the dot product of these two vectors is 0 means these two vectors are perpendicular to each other. Therefore, vector A plus vector B and vector A minus vector B are perpendicular to each other. Okay. So next is, if vector A, vector B and vector C, given three vectors, vector A, vector B and vector C, find lambda. So here we have to find the value of lambda, but question is continued, such that vector A plus lambda B vector and C vector are perpendicular. See here, given that these two vectors are perpendicular. Okay. First, let us find vector A plus lambda B vector. C vector is directly given, but we have to find this vector now. Okay. So here, consider vector A plus lambda B vector equals vector A is 2i cap plus 2j cap plus 3k cap plus lambda into B vector, multiply lambda to vector B. Okay. Here we get minus lambda I cap plus 2 lambda j cap plus lambda k cap. Okay. So now we have to add these two vectors. So here, first let us take the I components. 2i cap minus lambda I cap. So I cap is common. We get 2 minus lambda into I cap. Similarly, so 2 j cap plus 2 lambda j cap, that is 2 plus 2 lambda j cap plus 3k cap plus lambda k cap is 3 plus lambda into k cap. Okay, this is vector A plus lambda B vector. Okay. So C vector is given. What is C vector? 3i cap plus j cap. There is no k component. So here the k component value is 0. That is 0 k cap. So what is given? These two vectors are perpendicular. That is vector A plus lambda B vector and C vector are perpendicular. So perpendicular means, what is the condition? The dot product of these two vectors is equal to 0. So that is vector A plus lambda B vector dot C vector equals 0. So since these two vectors are in component form, so we have to apply component form formula, that is A1 into B1 plus A2 into B2 plus A3 into B3. Okay. So let us apply now. A1 2 minus lambda into B1 is 3 plus A2 into B2 2 plus 2 lambda into 1 plus A3 into B3 3 plus lambda into 0 equals 0. So here multiply 3 inside the bracket. So 2 3s are 6 minus lambda into 3 is minus 3 lambda plus. So if we multiply 1 with this term, we get the same term, that is 2 plus 2 lambda. 0 into anything is 0. That is equal to 0. Okay. 6 plus 2 is 8. Minus 3 lambda plus 2 lambda is minus lambda equals 0. So if we take this minus lambda to the right hand side, it becomes plus lambda. Therefore, lambda equals 8. So this is the value of lambda.